Hello, everyone. Thank you for joining us today. And we know your time is super valuable, so we'll get started right on time and get going with today's agenda. Um, the topic today is BigQuery, and I'm super excited to be talking about BigQuery. There aren't a lot of technologies that put a smile on your face, but BigQuery is certainly one of them. The more I get exposed, you recognize what a fantastic a platform that Google's built. So if there are any attendees here from Google, you've got plenty to be proud of. I think the scale at which it handles the flexibility of this platform and the evolution of this platform in the last couple of years has been amazing to watch. And again, it's technology that puts a smile on your face, and really happy and excited to be talking about BigQuery today. What's in the agenda? I think for a lot of people, this doesn't need to be mentioned, but there are some sellers and partners on the webinar today. So we'll quickly highlight, why is BigQuery so critical? What's the buzz about BigQuery? What's the buzz all about, right? And the main part of this webinar is really to just kind of dispel some of the myths around BigQuery data protection. A lot of people don't actually appreciate the exposure that they carry with BigQuery and just relying on inbuilt data protection capabilities within BigQuery. Um, and again, um, the use of BigQuery has evolved considerably in the last couple of years, and that brings with it unique challenges and something that we want to talk about and see if you're addressing it, the right way. And finally, we'll talk about what would happen if you lost your data set and you have to bring it back. What's your alternative if you aren't actually protecting that data set, right? Um, and hopefully we will have the privilege to help you with solving these problems. And I want to highlight, why HYCU for BigQuery and what's the advantage in using HYCU for us for BigQuery. And we'll also try to do a very short, very brief demo. My goal is not to get you all up and running today with BigQuery and HYCU, but if you want, you certainly can. It doesn't take a long time. Um, and we'll quickly give you an intro and a feel for the product without going into too many details. Again, the product is super simple, why it's named HYCU in the first place. So we'll do a quick demo, and if there are any questions, we'll take that as well towards the end of this webinar. So who's HYCU? Um, HYCU is the #1 SaaS data protection platform for as-a-service platforms, right? So that could be your applications like Jira, Okta, all your SaaS applications, M365, but also for a lot of the database as a service solutions. And just within Google, we're the only vendors that support BigQuery, Cloud SQL, Firestore, and AlloyDB, and so on and so forth, right? So a majority of the data platform is supported by HYCU today. We're used by over 4,000 organizations across the world, and backed by investors in the leading edge of technology and the venture arms of companies that are in the leading arm of technology, like Okta and Atlassian and Cisco. We're actually backed by these household names in modern technology, right? And don't just believe us. We actually carry the #1 NPS score in the market. So believe what our customers say. Don't have to believe us. We're also profiled in Gartner as a visionary for 3 years in a row. And we are the active Google Partner of the Year for data protection as well. And again, really keen to be talking about Google Cloud technologies and I think what is the centerpiece of AI strategy for Google today. And we'll start with the most obvious, right? Your organization, and most of you know this already, your organization cannot afford to leave BigQuery unprotected. What happens if BigQuery data doesn't exist today? That's a question a lot of you have to think through. Again, folks that are here today, I know you already know that it is critical and why you're here. Um, and for folks that are trying to get them educated on this ecosystem, BigQuery is the foundational element to a lot of AI initiatives for customers that rely on Google as the data cloud. It's aligned to revenue centers. A lot of critical business decisions get made out of data sets that are getting populated in BigQuery. And again, the use of BigQuery has changed from just holding a copy of your data in a specific format so you could go query and analyze. Now, a lot of data is landing straight in BigQuery. So the first hop for many of this data is actually in BigQuery, and that's where the only copy of those data sets actually sit. Um, and why BigQuery is certainly super critical, and those data sets are super critical for you to protect as well. So what are common threats to BigQuery dataset? As you know, with structured data, human element to data loss is very real and very common. Um, and lots of errors that do happen, schema changes happen that causes issues. Data ingestion pipelines have issues. You may end up loading it with the wrong data. People do accidentally delete. I was just reading a thread in data engineering in Reddit the other day where a gentleman was pointing out that he had two tabs open, one for production database and the other for production data set, and the other was a test environment. And he thought he was running a bunch of delete commands in test environment, but he was actually running them on production environment, right? So these things do happen. Um, and there's also organic changes that happen to your data set over time, which is why we protect a lot of our data sets, right? There is record expiration and partition expiration that happens based on certain policies that you have decided a priori, but those policies are happening happily in the back end, but in some cases, those policies are no longer relevant for the data set that you are keeping, and you may want to go back to a point in time where you can access those data sets. And of course, if you aren't thinking cyber threats today, irrespective of what your role is within the organization, I highly recommend you do. Security is now everyone's responsibility, irrespective of what our roles in professional organizations turn out to be. And of course, outages don't happen, but no cloud provider is immune to outages. And having a plan is essential for anything that is of importance to an organization. And I want to highlight also that data loss is not some theoretical concept. Even in BigQuery, these things do happen. People are asking questions about how do I retrieve a data set that was deleted like a week ago. There are some changes in my infrastructure as a code, and that went and then deleted a bunch of things in my data sets. These things do happen, and probably the most popular case and the most extreme case doesn't certainly happen often, but it did happen, right? It's a UniSuper is a big, I think $100+ billion pension fund. This is the retirement accounts that people have in Australia, and UniSuper is one of the largest manager of those. And their account just got deleted because of a configuration change within the cloud provider, and they lost all their data set. Again, luckily, someone had the foresight to have done backups. Took them several weeks to kind of get it back up and running, but they at least were able to do that. But these third-party risks do exist, and it's something that every organization needs to plan for. Now we get to the myths with BigQuery. A lot of people think they don't carry as much exposure with BigQuery as they do with other places, and that might be true, but that doesn't imply there is no exposure with your BigQuery environment. And a lot of people also think just because you have data sets in the cloud, the data is protected, and that's actually our number one myth. Um, Protecting BigQuery is Google's responsibility, not mine. If you are from the infrastructure world, and this is a very well debunked myth, there is a concept of shared responsibility. Google is responsible for keeping the BigQuery service up and running. They're not responsible for your data. You are responsible for your data. You're responsible for protecting your data set. That's not Google's responsibility. And again, that comes from the shared responsibility model. But again, it's perfectly understandable if you aren't from that space to think I have a managed service, then they must be managing all these things, including backups, right? So it's not wrong to carry that assumption, but it's just not reality, and it's something that you need to align to with BigQuery, just like any other as a service platform that you may be using today. The second thing I hear often is, hey, BigQuery is immutable, it's append only. I really don't need to be considered with cyber or insider threats or even data loss in general. Yes, BigQuery is immutable. Yes, it is append only, but that doesn't imply that your data sets cannot be changed, period. Right? There is the concept of partition expiration. There is the concept of record expiration. There's a concept of overwriting, entire tables and data sets, and those things do and can happen. And it's not immutable in the same way that people think about. It's not immutable as a whole, but each record you store is immutable, and you can only create a new version of that data set. So it is not always a well understood concept, and people don't appreciate that you can actually lose data in BigQuery. And the third myth we'll talk about is time travel, which is going to be a topic of considerable importance today on this webinar. People assume, hey, I've got time travel. I've got all these native tools like failsafe and so on. And these tools are enough to cover me. Um, these tools exist because there is potential for data loss, right? You want to be able to go back and look at a point in time where your data was in a specific state. Um, but what but a time travel is only available for a maximum of 7 days. I think a time travel is somewhere between 2 to 7 days that you could turn on for, right? So you can either go back up to 2 days or you can go back up to 7 days. But that's the window of time. You have the availability and the optionality to go back to a point in time. But errors aren't always discovered in 7 days, especially when you have lots of data sets that are only accessed once a month, once a quarter. You've got some trending analysis you're doing, and you've got some reporting you're doing towards the end of the month or end of the quarter. There are data sets sitting there that don't always get touched every week, every day. So those are data sets that you may be losing without the optionality to be able to go back. And why time travel again is doing a wonderful thing. It's a wonderful piece of technology, but it is limited in how far you can go back. And that's not something a user can control, and why other solutions exist, right? So what are the native tooling? This is a great time to just kind of introduce the native toolings within BigQuery and Google Cloud, right? There is time travel. Again, awesome technology, but what are some limitations? It's primarily on table and not on table metadata. It's limited to 7 days. That's what I would consider the primary limitation. You can only kind of set up time travel for a maximum of 7 days. But what happens to potential data loss that is discovered after 7 days? What happens if you want to go back to a point in time that's earlier than 7 days? That becomes a problem, right? And also, if you use things like row-level security policies, time travel doesn't become a self-service component. Only a table administrator could actually do, and you leverage time travel today. And those are certain limitations to just keep in mind when you're relying solely on time travel for data sets. And we work with a lot of customers, as I said, 4,000 plus customers at HYCU, and I've been in the industry for 17 years. It is very rare for organizations to say, my data protection policy is to retain data for just 7 days, right? That just doesn't happen in the real world. Majority of customers we talk to retain it at least for 30 days, but very often 60 days, 90 days, 1 year. And if you're a regulated industry, sometimes 6 and 7 years. or even forever, right? And that's the requirement. 7 days is a brilliant short-term solution you have in hand, but not a long-term answer for a lot of potential needs that you have with your data set. And then there is failsafe. Failsafe is what I call undo option, but it's not exactly self-service undo option. If you delete a data set and you want to bring it back, you have a 7-day window where you could call in, even if your time travel doesn't cover it. Every data set that you delete from BigQuery, there is a 7-day window where you could call into support and ask for that data to be restored back. Um, Again, not self-service, another 7-day of coverage. So it does extend your coverage window a little longer, but doesn't solve the problem altogether. And then there are table snapshots and exports. We actually leverage both of these in our own solution. So these are, again, excellent tools that are available, but when used correctly, right? With table snapshots, some considerations that you need to keep is anytime you do recluster, those snapshots grow up in size. And more importantly, you're keeping the data set right next to your base table data, right? So you're not actually increasing your failure domain. In plain English, a lot of people would call that all eggs in one basket. Everything, your primary copy as well as your secondary copies, are essentially sitting in the same failure domain. And that is a risk, and uh, uh, that doesn't follow the best practices with data protection. And then finally, you have exports. Again, we leverage exports for our backups as well, but there are limitations there as well. Again, exports are really only used for base table data. You don't get to export all the other things in your data set, like your views and queries and so on. And also, time travel data is not captured when you do export. An export is a point in time capture of your base table. And there are reasons why that is an important thing to consider, because you have to decide what is that point in time you're going to capture that export from. And there are implications to it, and we'll cover that going forward, right? So again, we walked through all the capabilities that are available. We also talked about specific considerations with those capabilities. Now, there is also a school of thought that, hey, I'll just recreate the data set. I mean, majority of the data that I have in my BigQuery data set is a copy of another data that I have somewhere else. I'm connected into Cloud SQL and I'm pushing a whole bunch of databases there. I'm connected into Salesforce and I'm pushing data there. So you have a lot of your data sets already kind of sitting outside. So why bother to protect BigQuery? That's a common thing we actually hear from customers we talk about. What you really have to understand is that recreating that data set comes with real cost, both in terms of dollars, in terms of time, in terms of opportunity cost, right? Think your ETL expenses, think your data ingestion expenses. I mean, if you're streaming that data set for importing, think the 5 cents a gigabyte that you would be paying. Think about if you're using a Fivetran, Rudderstock, or one of these data integration tools, you're paying for every row that it gets processed through these tools as well. If you're using streaming APIs, say you're reading from Twitter, right? To rebuild a data set, you have to be at the highest plan, and those plans cost as much as $500K a year for an organization to be able to search and store over 50,000 tweets in a short period of time. And Salesforce will force you to move up a level in terms of their licensing plans to be able to buy additional API calls as well. So these are all costs that you have in recreating a data set. So yes, in theory, you can recreate a data set if you're not just, if you don't have reliance on streaming or streaming real-time data that is stored only in BigQuery. But there is real cost in terms of both time and money when it comes to recreating this data set, right? And this is why backup use cases exist. So think of it as a timeline. If you spot errors early, you've got native BigQuery tooling that can help you. If you spot errors late, you need third-party solutions like ours. There aren't very many third-party solutions. We're actually one of the very few, I think only a couple of vendors out there that do BigQuery backups. We provide the solution that is needed for these use cases where you need to go back further in time. So let's talk HYCU and how we solve these problems for you, right? Just a high-level introduction to HYCU, and I mentioned this earlier. We actually protect more services in Google Cloud than Google's own data protection service. Certainly anybody else in the market, right? We were the first ones to introduce backup for Google Cloud. It is the largest portfolio we carry among public cloud providers within HYCU. So there's a lot of focus placed on Google Cloud and Google Cloud customers and enabling them to safeguard their data protection, safeguard their data is again a crucial part of what we do in this ecosystem, right? And we'll show you a bit of the UI. I won't read through the slides, but a key aspect is we cover multiple services through a single policy engine, through a single user interface, a single experience, and all SaaS. So if you're used to the ease of use of BigQuery, of being a serverless architecture, you get the same benefit with the HYCU as well, right? And here is another myth we talked about before I actually talk about how HYCU solves it, right? This isn't about people saying, hey, my data is already protected. There are people that actually do protection today, but they believe that the backup that they are taking is actually consistent. And what I mean by that, right? And when you take a snapshot today on tables, or when you export, various tables, they're not all happening from the same point in time. So you're effectively creating a copy of your tables and data sets from very different point in times. That could be a couple of seconds apart, that could be a couple of minutes apart, and that could be a couple of hours apart. And there is lots of people with lots of data sets. And again, we compartmentalize for good reasons in BigQuery. We don't want to be reading more data than we need whenever we run our query, because that's how BigQuery works. You're charged for how much data you read when you read that data and when you use that for analysis, right? So you actually do compartmentalize these data sets for good reasons. And you have views potentially in one data set that is referencing another data set. If those data sets are protected, not from a common consistent point in time, but actually very disparate points in time, is that data usable when you bring it back, right? That's an important consideration to have. And actually, some of our customers did have that consideration, and they came to us and said, hey, it's great that you do BigQuery backups, but my situation is that I've got views that reference multiple data sets, not just the data set that they're part of, and I need to make sure that I get a consistent view across all my data sets. So we built something called atomic backups. And what this does is that we actually line up all of these tables to a single reference point, and we take backups of your data set from that single reference point. So when you run a backup at 10 a.m., all your data sets, whether they get backed up at 10:02, 10:04, 11 o'clock, 12 o'clock, depending on what size of data sets that you have, irrespective of when we get to backing up a data set, they will all look like how they existed at 10 o'clock period. And that's the atomic backup that we deliver. A lot of people believe their backups today are consistent until they actually start to use it. And atomic backups are a great way to establish a single reference point across your tables and data sets. And again, keep in mind that when you export, you don't have time travel data. So you don't have a way to roll forward, roll back to a point in time. You don't have that optionality during recovery. So you have to line up these data sets during backup time. And that's what we do, right? Um, and the second advantage that I want to quickly highlight is that we protect BigQuery beyond just the tables. It's great, and tables are, of course, the building blocks of everything you do in BigQuery. But there is just a lot of things that are sitting on top of a table within BigQuery, right? There's stored procedures, there's functions, there is models, there are views, there is table schema that has got important information. There is row level security policies that control access information on who gets to access which of your rows and data sets. I mean, who protects all of these things and brings it back, right? Something that HYCU does. In fact, we're the only solution in the market that protects not just your base tables, but everything around it as well. So that when you bring back the data set, you're not creating a new access control problem. You're not creating a new clustering or a partitioning problem. We actually bring it back intact. Your views and the definition of your views will all be intact. So you could actually get up and running very, very quickly, right? And the other thing I want to highlight is we are uniquely qualified in the ecosystem to protect not just BigQuery, but also a whole bunch of your connectors, right? BigQuery is over 80 GA connectors today and a whole lot more that's not quite GA yet. We support about 80 as a service applications, and many of them have direct connectors to BigQuery. So you not only have to you can not only back up the post ETL BigQuery data, but you can also back up the source applications and be able to bring back those source applications as well. So we can be one solution for not just your BigQuery, but also your other things in your data estate, right? So this kind of gives you a high-level view of everything that we protect, whether it's hybrid cloud infrastructure, whether it's modern public cloud infrastructure, or simply as a service applications, things like Git, things like Terraform, which you may be using today, those need to be protected as well. Things like Jira and Atlassian products, and your identity management projects like Okta, which may be what you use to manage your identity. Those are things that we protect as well. So it can be one solution for a lot of things in your infrastructure. People say a picture is worth 1,000 words, and I always say with my accent, it's worth a whole lot more. So I'd love to quickly just give you guys a feel for our BigQuery solution and our UI. Again, my goal isn't to get you guys all up and running with BigQuery today, but if you're interested, we could certainly do that as well. Just hit us up. But the goal is to just give you guys a feel for how BigQuery shows up in our UI, what options exist, how do we leverage some of these capabilities, and how do we make life easy for customers like you, right? Let me just switch to my demo. Hopefully everyone can still see my screen. Let me sign in. Got a couple of windows. So in our solution, this is a great place to get started. We are one of the few that can actually go ahead and identify everything that exists in an organization. How do we do that? We have a great asset discovery solution called rGraph, and that becomes kind of the central point of everything we do. As I mentioned, HYCU is a SaaS solution. So all you do is really get a login and you're in the screen already. And once you connect to your IAM account, we can see where all your single sign-on access is getting utilized, right? So that can go and identify the various platforms that you're actually using. And within those various platforms, you could see, hey, what applications are you running and what solutions exist and whether the data is protected, not protected. We can actually go and discover your data estate and actually tell you, what's protected, what's not protected. So this is a great place to start. Allows you to visualize your entire platform, and also kind of highlight, where you may have gaps, right? So let's kind of talk about how do we get started. You've got concepts of cloud accounts and cloud sources. Doesn't need a whole lot of explanation. You can essentially add a cloud account. So simply add a Google Cloud Service account, and go through the process, and that allows you kind of access into the broader Google Cloud account. And you can add individual sources by simply going into a SaaS, create a new source. And in this case, if we choose to add BigQuery, really just add BigQuery. And if you've got already a HYCU managed account, simply provided grant access, and you could get up and running. And this should allow us to see all your BigQuery instances pretty quickly. Of course, you need to have the right IAM and privileges and the permissions. Once you assign those permissions, we can essentially see what BigQuery data sets that you have running. So where does it show up? We have a whole bunch of things that we protect, as we talked about. SaaS is where a lot of our as a service applications will show up. And here, as you can see, I have a lot of different applications. I've got cloud functions I'm getting backed up. There is BigQuery I'm backing up. There is some AWS resources I'm backing up. There is Cloud SQL. There's a LightDB, backing up a lot of different sources in this platform. Let's focus on BigQuery. So I'm going to filter my data sets for BigQuery. And as soon as you discover, you can actually see all your BigQuery data sets right here in the platform. And let me quickly show you my BigQuery project here. Not a ton of data sets here, probably compared to some of your production environments. They are really small data sets with small footprint. But you can see there's a bunch of data sets here, and they're all detected here. I actually have multiple projects within our account that's got BigQuery. That's why you're seeing more than what I am seeing here. That's because, again, more than one project is scanned in here. But you can see everything in my project shows up here, right? And once it shows up here, you really just assign policy. You go ahead and set policy. There's a bunch of policies. I've got a policy for BigQuery alone, but you can actually apply any of your gold, bronze, silver policy that defines, what should your retention be? How often do you want to back up? Where do you want to keep that backup? Whether you want to have object lock enabled, whether you want to have it offsited to a different region, all of these questions you effectively set up in your policy, and you simply assign a policy, and we will run these things for you going forward, right? So this particular data set's got a backup policy, a copy policy. We do an export, and we actually copy that file to a different region. So you have that data set in a couple of different places. And again, we do that within this platform for any data set. Let's talk about atomic backups that I walked you through, right? So in my data set, I've got a couple of data sets that are interlinked. I've got routines and views that kind of go and look into the other data set and other tables. So I'm actually trying to group these two data sets together so they actually get backed up at the same point in time. So that's accomplished by assigning a label here in my BigQuery data set. I've assigned a label that says HYCU group them together, and I'm calling them atomic backup. I do the same thing here. You can create multiple groups. So these two data sets can be called atomic backup. You can have a couple of other data sets that you call them atomic backup 2, or whatever you want those names to be. And these would show up in our interface as a grouped object. So like in this case, this is actually a group data set. There are more than one data sets that are grouped together in this. And you can see which data sets are grouped together. And those, again, get backed up. When they get backed up, both these data sets and all tables within these data sets get backed up from a single reference point in time. And so that they, again, remain consistent with each other. with these data sets, right? And from here, you could go ahead and restore these data sets. You have the option to restore um, individual files. You have the option to restore entire data sets, and you can select them through this portal. When I run this takes a minute or two usually when I run it live, simply because we're kind of spinning up a transient worker node in the backend, reading through the data we have stored in a repository, and essentially going to show what recovery points you have available, what can you restore, blah, 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 right? So let's actually show from a storage perspective what that looks like when you do backup. As you can see, we back up not just your data sets, we're backing up your routines, your tables, your views, all of these other things as well. So that when you restore an entire data set, you've got the ability to bring up not just your tables, but everything that's kind of sits on top of that, and treat it as an entire application, not just the bits and bytes or records in the world of BigQuery. We actually have to think about how do we get that functional in a new environment if you ever have to restore, right? So we do that, and that's again unique thing with HYCU, as far as I know at least. HYCU is the only backup solution that backs up not just the tables, but also all the data sets. And uh, and HYCU can establish a single point in time snapshot across multiple data sets as well. Doing that through internal tooling and scripts, tend to take a lot more time and energy for our customers, right? So if I choose to do a restore, this is a data set, got a couple of tables you can actually see, and you can actually pick which tables you want to restore and restore them, or you could do an entire data set and try to restore them as well. And in that case, you can actually select, you want to rename these files, and what do you want to do. There's a bunch of options that you can enable, and you can actually perform these restores as well. Again, my goal is not to walk you through every option that is out there, but simply to show you that you can very quickly identify BigQuery datasets with simply permissions, right? Once you scan them in, you can see all your estate. Two, you can organize them in the fashion you want and in completely under your control. Simply create labels that allows you to organize your data sets. And as you add new labels to new data sets, we would automatically pick them up, discover them, and add them to the right groups. And define backups on a policy, not just to the same region, but also potentially to a new region, whether you want it object locked, that's something you could do. Today, if you are natively doing BigQuery exports with object lock, you have to do the export and then turn on the object lock, right? You can't actually turn on the object lock uh, before the export happens. But once you turn on the object lock, you cannot use it again for the next export. So you have to have a new bucket that you create and do the export and then turn on the object lock and so on. So it becomes a lot more difficult to handle these unique capabilities on your own. We deliver that through a policy engine. You assign a policy, we run it on a regular basis, and when you want to do restores, we've got all that data protected. So when you restore, you simply go through a wizard that identifies what is available for recovery, select your options, and you can go ahead and run your recovery. And BigQuery does the rest. And BigQuery does what it does best. It's fast. We've got customers that are backing up over 5 terabytes of data set in a minute, right? And that's how fast BigQuery backups are. So don't, again, a lot of data can be pushed and protected in a very short period of time with the wonderful technology that BigQuery is built, and we'd be happy to make that possible for you if you choose to do so, and I hope everyone chooses to do so. So just a quick wrap up. Um, if you would like to get started, we have a data sheet available online. Just scan this QR code and it would direct you right there. You can also request to start a trial. We'd be happy to be in touch and kind of talk about your requirements. And also, if you know of any myths that we didn't address, find us in LinkedIn. Happy to connect with any of the attendees today. Find me in LinkedIn, shoot me a note. Would love to kind of hear your perspective. And also, if you have any unmet needs with BigQuery, hey, I'm trying to do this on my own, I'm not able to solve this problem. Best solutions are built when customers tell us they have an unmet need. That's how we built Atomic Backups. That's how we started adding, backups of views and routines and functions. So tell us, what your unmet needs are, and we would be happy to build a solution around your needs and make it possible for you. So we'd love to hear from you, and just hit us up through any means and as necessary. So with that said, thanks everyone for joining today. Let me quickly check if there are any questions. If there are no questions, I'll give you back the time. There are no questions. Um, and again, questions don't have to be today. I know there's a lot to process, but if you have anything, just hit me up in LinkedIn, um, and happy to connect with each and every one of you. Thanks again.